All right, y'all. Before we start notes, well, first I want you to write the title of your notes. So 0.3 notes, difference of squares, and complex roots. But before we start the notes, I want you to think and tell me, name some numbers that you can square root. I'm going to say that you can square root and then remind you that's the square root symbol. Okay, so name some numbers that you can square root. All right, so now that we've got some numbers that we can square root, let's talk about why we even did that exercise. Okay, so write down this example. And actually, before you write the example, get this little title down: Factor quadratics with two perfect squares. And this is called difference of squares, and we will a lot of the time label it DoS. So if you ever see me write DoS, I'm talking about difference of squares. Okay, so you should have that title down. Now write your example. Example, factor f of x equals 16x squared minus 25. Then find the zeros, roots, solutions. Okay, so why are we talking about square rootable numbers? Numbers that we can take the square root of, perfect squares. Because, come over here, if you notice that a and c can both be square rooted, a and c can both be square rooted, and that the x can also be square rooted, use difference of squares trick to factor. Okay, so what am I talking about? Well, let's first name what is a. A here equals, that's the number that's on x squared, so a equals 16. What is b? B is the number on x. Do we see any x's here? No. So b must be 0. That's all right, sometimes b is 0. And what about c? C equals the number that's by itself, negative 25. All right, but we're not going to stress about the sign on c. Let's just think about this statement. If you notice that a and c can be square rooted, so forget about the sign. Can we square root 16? Yes, we can. What is the square root of 16? 4. Can we square root 25? Yes, you can. What is the square root of 25? 5. So, yes, a and c are square rootable numbers. Let's keep reading. X can also be square rooted. X can also be square rooted. So, here's our x. We have x squared. Can we take the square root of x squared? Yes, we can. What that's going to do is it's kind of like dividing your exponent by 2. So the square root of x squared gives you just x to the first, because 2 divided by 2 is 1. Okay, so we just have 1x here. So why are we doing this? How is this going to help us factor? Because this is an amazing trick. If you can square root all 3 pieces, we can square root this piece. Oh, this is not working. We can square root this piece, and we can square root this piece. Oops. If that's true, if you can square root all 3 pieces, then you can use the difference of squares trick, which means when you factor, you're just going to take the square root of each piece. So watch what I do. Square root of 16, we're going to start with the 16. Here, I'm going to write what we started with here. So going back to what we started with 16x squared minus 25. And now we're going to factor that using difference of squares. Square root of 16 is 4. Square root of x squared is x. Square root of 25 is 5. And your factors, they always are like 2 parentheses, right? And there's a plus or a minus in the middle. Pick one, plus or minus. I like to go with minus because I copy this sign. And then square root of 25, 5. So 4x minus 5. And then we have to copy this. We're going to copy this because we need a second one. 4x plus 5. And you flip the sign. Do you see how I went square root of 16, 4, that also shows up here. Square root of x squared, x, that also shows up here. Square root of 25, 5, that also shows up here. And then we just have the opposite signs. We flip the signs in the middle. You get two factors, opposite signs. And sorry, that pink is like super bright, so I'm going to erase it really quick. Plus 5. Okay, so now you're going to try. I want you to try difference of squares. But again, I always throw a more complicated practice at you. What needs to be done here? Tell me what needs to be done here before we can start factoring. Okay, hopefully you said we need to move everything to one side of the equal sign. The x squared is already positive, so I'm going to leave it there. So what I'm going to do is minus 49 on both sides. These cancel out and make 0, so we have 0 equals x squared minus 49. Okay, so what we're starting with is x squared minus 49 equals 0. I want you to get the factors to that. Tell me what those factors are. Okay, so we're going to use the difference of squares trick. Can we square root x squared? Yes, we can. Can we square root 49? Yes, we can. The square root of 49, just so you know, square root of 49 equals 7. So we can square that, or square root that. So we're going to do the square root of x squared, which is x. We're going to copy this minus. We're going to do the square root of 49, which is 7. Put that in parentheses. That's one factor. Then we're going to copy this factor exactly how we see it, except we're going to flip the sign. Boom. There's our other factor. Okay. Now I want you to do, let's go back to this problem, the example problem. I want you to tell me what are the roots, the zeros, the solutions to this example problem. Go. Okay, you should have set, you could either use the trick, which I'm going to show you in a second, or you set this factor equal to 0, and you set this factor equal to 0, and you solve for x. But the trick tells us that we can flip the sign, so we're going to say x equals positive, then we use this number first, 5, then divide, use the 5 first, then divide by whatever number is touching x. Positive 5 over 4, and x equals, flip the sign, negative, use this number, 5, divide by whatever's touching x, over 4. Boom. We had two solutions. And if you want, you could write x equals plus or minus 5 over 4. Because it's the same number, right? Just different signs. All right, I want you to use a trick, and I want you to tell me what is x equal for this guy over here. What are your solutions, your roots, your zeros, your x-intercepts? Go. All right, this one should have taken like 2 seconds. You get, flip the sign. X equals 7, x equals negative 7. Or you could say x equals plus or minus 7. Cool. All right, moving on. We are going to do a problem where we solve quadratics with complex roots. So write that down. Solve quadratics with complex roots. Okay. So it's telling us to find the zeros of this thing. That looks like something I can factor, right? So let's try to use the box method. Let's try to factor this. We need to multiply to a, which is 1, times c, which is 5. So we need to multiply to 5, and we need to add to negative 4. What numbers can multiply to 5, add to negative 4? Well, if we do our little table, 5 and 1 multiply to 5, can those add to negative 4 and multiply to positive 5? We could make this negative, but then it would add to negative 4, but then it wouldn't multiply to positive 5. So here's the thing. Sometimes the box does not work. Sometimes there's no numbers. There are no numbers that work. Nope. Nothing works. In that case, you probably remember you need to use the quadratic formula. So let's write that down. Quadratic formula. And this is important on SAT. So we're going to go over it again. It's x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Sweet. And what does it mean by a, b, and c? These a's, these b's, these c's. Those are these numbers. A, b, c. So we're just going to plug in. So for this one, a equals, for this problem that we just tried, a equals 1, b equals negative 4, and c equals positive 5. Cool, so let's actually plug in and use the quadratic formula. X equals negative, and then b is negative 4. So I'm going to plug in negative 4. It's always good to put parentheses around what you're plugging in. Plus or minus the square root of b is negative 4 again, so negative 4. I put parentheses around it when I plug it in, squared, minus 4. Now I need to plug in a. A is 1, and c is 5. All over 2. Do you see how I'm putting parentheses around everything? That's really good practice for SAT. It's going to make sure we don't mess up our operations. Now we simplify. So I'm going to come over here and simplify. X equals negative 4, that turns into positive 4, because a negative times a negative is positive, plus or minus. Negative 4 squared is 16, minus 4 times 1, that is negative 4 times 5 is negative 20, all over 2 times 1 is 2. So we have this. We need to further simplify it. I'm going to go over here. X equals 4 plus or minus 16 minus 20 is negative 4. Don't forget we still have our square root over 2. Okay, there's one more thing we need to talk about today. It's this, the square root of a negative. The square root of a negative. When you square root a negative, a funny letter pops out. I don't know if y'all remember what letter pops out, but when you square root a negative, you end up getting an I. The negative sign, think of it as the negative sign comes out in front, it leaves and turns into an I. So we're going to write x equals, I'll use this, x equals 4 plus or minus I, then the negative's gone. Square root of 4 over 2. See how the negative disappeared on the inside of the square root? Because it turned into an I on the outside. And now we can simplify further. X equals 4 plus or minus, okay, what is the square root of 4? Square root of 4 is 2. So we're going to do 2 times I always like to put the number before the letter, over 2. And we are almost done, y'all. We can think of these as 2 separate fractions. So we're going to kind of split it into 2 fractions and simplify. We have this fraction and this fraction. So let's do the first one equals, we get 4 divided by 2. 4 divided by 2 is 2. We still have plus or minus. 2 divided by 2 is 1. I is on top still. So 2 plus or minus I. That is our solution. I is an imaginary number. So really quick, in your notes, write I is imaginary. And I equals the square root of -1. Another thing that's good to know about I is that I squared equals -1. So you need to know all these things about I. Write those down. Those are important for SAT. I is imaginary. I is the same as the square root of -1. And I squared is equal to -1. Cool. That's notes for today, y'all.